Good morning. We're going to talk a little bit about stuff that's beyond PHP, stuff that has to do with all the little icons around the blue elephant there. Let me quickly start by telling you who I am. My name is Wim Godden. I'm from Belgium, that little dark green spot in the heart of Europe, best known for stuff like Belgian beer and Belgian chocolate and other tasty, yummy things and odd buildings that we build. My town, we have a beautiful castle and a couple of abbeys and stuff like that, but also have a little bit of traffic, and smack in the middle of that I started a company about 15 years ago called Cube Solutions. I've been doing open source since around 1997, working mostly with PHP. Worked on PHP compatibility and a few other things. And I've been doing talks like these for the last couple of years. I quickly want to tell you something about the company I work for, because I'm going to get back to that in a minute. So we do a lot of open source stuff, mostly PHP. We do some training courses and stuff, but we also have our own high-speed redundant network. So we have a lot of network knowledge in there. We have a lot of system engineering knowledge. We work a lot with high scalability. And the customers that we have are mostly IT and telecom operators. And we work a lot on public-facing apps, so pretty big websites. Okay, that's enough about me and the company. Let's see who you are. Who here is a developer? Yeah, most of you. Who here has ever set up a MySQL master slave? Not so many. Okay. And how many of you have ever set up a site or an app that runs on a separate web server and a separate database server? Now keep your hands up if you know how much data runs between those two servers. Right. You can see where I'm going with this, right? So we're going to talk about stuff that's not so typical. So the topic is the things we take for granted, also known as it should work fine, also known as it works fine on my laptop. So whatever works fine today on your laptop might not work as well in production tomorrow. I'm not going to be talking about the most common mistakes. We've all made them. We've all learned from them, I hope. But I want to talk about PHP code and how it interacts with the bigger ecosystem. But of course, it all starts with the code because we're developers. And what do we interface with the most from our PHP code? Database, right. So let's talk about database. I don't want to be discussing this. You should not be writing queries like this. Can anyone tell me which tool produced this query? I'm sure you cannot read it at the back, but... Access? No. It's my favorite tool of all called Drupal. There's stuff happening here like interval add 0 seconds and stuff like that. Why would you add 0 seconds to something? This is what happens, of course, when you have a tool creating queries for you automatically, which is not ideal in most cases. So I don't want to discuss this. I do want to discuss indexing, because indexes make our database a lot faster in most cases. So let's imagine that we have this little query, select ID from stock, where the status equals to order by quantity. Where would I place an index on the table stock? Sorry? Status, yes, definitely. ID, there's probably one on there already. So in this case, what you want to do is have an aggregate index on status and quantity. But what happens if I do this? I just say status greater than 2. Is it still the same? Now you might probably think, nah, it's probably not going to be the same. Might be a trick question. Not the same. So what do I want?
Quantity status.
Quantity status. Huh. Interesting. Actually, the answer here is it depends. Because it depends on the kind of index you're using. If you're using a B-tree index, then the answer is yes. If you're using a hash index, then the answer is no, you need a range selector. As soon as you have the range selector, the greater than, it stops actually using the index. So in that case, you need 2 separate indexes. Well, and that only works if you're using MySQL 5.7 and higher, I think, or 5.6 and higher. So it is important to know exactly what kind of an index you need for your specific query here. Which brings me to the point of people say, okay, indexes make databases faster, so let's just index everything, right? So we have 50 columns, let's put 50 indexes on there, and then let's make aggregate indexes across them and so on. But please don't do that, because every time you do an insert, an update, or delete, you're actually going to have to rebuild those indexes. And every time you do a select, you're going to have to evaluate, hang on, I'm doing a select, I have 50 indexes, which one am I going to use to run this select? So it's going to slow things down a lot if you're using too many. So there's this quote by Bill Carwin, which says, relational schema design is based on data, but index design is based on queries, which basically means if you're designing your app and you're putting your data in different tables, yeah, that's when you actually design your schema. But you don't add any indexes yet. You only add your primary key and your foreign key. Only when you start adding your actual code, when you start writing your queries, that's when you know what you're going to query and which exact indexes you're going to need. That way you have just the right amount of queries, indexes. So let's say we have problematic queries. How do we detect them? Well, there's a couple of ways of doing this. I'm talking mostly about MySQL here, but most of this works actually for most database servers. So in MySQL you can just turn on the slow query log. That will output any queries taking more than a certain set of time. Now how much that time that is, you can define it. It depends on your exact distribution, what the default is, and so on. So it will show you the queries that take, for example, 5 seconds to run. Might be useful to have a look at those. There's also, this is MySQL specific, there's a parameter called log queries not using indexes. I don't think I have to explain what that does. There is a caveat here. This only works when you have the slow query log on. I don't know why. Then the next thing you can do is you can turn on the general query log. Now this is a very interesting one. It will output every single query running on your database server. So if you're running it on a production machine, you don't want to have it turned on, because if you're doing 50,000 queries per second, you're outputting 50,000 lines in your log file. That could actually bring down your machine. Now you might wonder, why do I want a log file containing all the queries in my entire system? Well, there's a tool called Persona Toolkit. It's actually a toolkit. But there's one tool in there called PD Query Digest. And if you provide this tool the log file that you got from the general query log, it will output something like this. I'm pretty sure this is not very readable at the back, but I couldn't make it any bigger than this. Basically, it will show you which queries are being run the most often and how much time they take exactly. So in this case, for example, we have one query that's being called 1208 times, and it takes 13.6 seconds per query. That's using a lot of CPU power. Probably you could optimize that query. Now, this is just the first part of PD Query Digest, because underneath that, you get a lot more per query. And then you can see how much time is spent locking, how much time is spent transferring data, how much data is retrieved, and so on. Because maybe you're retrieving way too much data. You might be doing select all instead of selecting 1 or 2 fields. Now, once you know that, once you know which query is taking the longest amount of time, then you can run explain on it. Again, similar commands in similar database servers. In other database servers. So you just run explain, and then you provide a query, and it will tell you how MySQL will interpret that query. So for example, this is the output of a simple query, and as you can see, it does a query on one table called employees, and it's doing type all, which basically means it's retrieving every single record in the entire table. This is not a good idea, obviously, because we're retrieving 300,000 rows here. You can also see that the possible keys are null, so there are no indexes at all on this table. Not a very good idea. However, this one is a join between 2 tables, and you can immediately tell that the possible keys are primary and another one, a foreign key, and we're actually using the key primary, meaning we are retrieving 1 row. This is a much more efficient database query. Now, if you see type of lookup in that output of explain, system constant ref, that's good. If it says all, you're doing a full table scan, that's very bad. If it says using index, that's very good. If it says using file sort, it's usually bad unless your result set is very, very small. Now, using for each So ever heard of the n+1 problem? See a few people nodding. Yes. So this is basically what happens. So you do a query on a customer database, and let's say you have 1,000 customers, and you get 1,000 rows back, and then you're going to loop over them and look up all their contacts. So you're now doing 1,001 queries, which is not really efficient. You want to always avoid using for each or for in this way. You could just replace it by a simple join. Now you have one query instead of 1,001. And it does exactly the same, gives you exactly the same result, basically. So yes, it's better. But people still do this. And the reason they do it is usually it's a combination of two things. First of all, they don't expect to have more than 5 customers. But then they get bought by some company, and that company has 1 million customers, and now this thing is doing 1 million queries. Or they're using an internal app, and they wrote it quick and dirty, and then the manager comes along and says, that's an interesting app. We could actually offer that to our customers. Let's put it online. Now you've got a lot more people hitting it. So why am I doing this talk? Well, it started off basically, we build stuff for customers, but we also get dragged into stuff that others build, and then we need to upgrade something or make a small modification, stuff like that. So this is basically a talk about 15 years of total havoc with 2 lines of code. And I'm going to illustrate that by using 3 clients. I'll call them X, Y, and Z because I don't want to share their names. They wouldn't be too happy about it. Let's start with Client X. Client X has a job search site. So you can go on that site and type, I want a PHP job, and it will give you 50 results back on the first screen, and then you click next and you get another 50 and so on. And they monitored how many times each job was actually viewed. They had daily hits, weekly hits, monthly hits, and then they also logged which users saw which job. And they had 4 tables to do that. And they had a primary key, and everything was working sort of okay, and they reset that counter every now and then, every week they reset the shown week 1 and so on. And this worked pretty well. And originally, they wanted to know when the job was actually clicked and when the user saw the actual details of the job. But then the marketing department said, actually, we don't like that. We want to know when the job appears in the search result. Fine, no problem. So the only issue there is if you search for PHP and you get 50 jobs back, now you want those 50 jobs to be updated, the counter of it. So that means 50 updates for shown today, 50 for shown week, 50 for shown month, and 50 inserts for shown user. That's 200 freaking updates, 200 freaking queries for one search result. Now how do you think they implemented that? Yeah, let's do a for each across that. So they had 4 queries that did insert into and then on duplicate key updated, which was fine. That was a nice query. But then doing a for each across that, maybe not such a good idea. Now, what we've been doing there, we haven't been writing code there. We just set up the MySQL master slave on their new infrastructure. And we had made beautiful graphs using MySQL Enterprise, and this is what happens. Everything was working fine, and then all of a sudden you see those peaks there, which is when they applied the for each loop. Now, we weren't actually actively watching this because nothing was telling us something was wrong in terms of too much load. But they were doing 600 to 1,000 inserts a second, up to 1,000 updates per second, but it was a 16-core machine that had lots of CPU power on there, so not an issue. Until the client called us panicking, saying, we got a mail from your monitoring system, the MySQL Slave is now running more than 5 minutes behind your master. What's going on? Now we set it up, who do you think they blamed for it? Yeah. And we said, wait, hang on a second. We looked at those graphs. What the heck is causing those peaks? We didn't change anything to the infrastructure, so something must have changed on the other side. So we asked the developers, did anything change? And they said, nah. So what do? Well, we turned on the general query log. We ran it through PD Query Digest, and at the top we had 4 queries now. shown week, shown day, shown month, and the shown user. So we went back to the developers and they said, well, maybe we make this tiny little change. We added a for each somewhere. So the issue was that after 3 days, it was only 2.5 days behind, and every hour we added 50 extra minutes. So the manager basically told us, it's fine, it'll catch up during the night. No, won't. Yeah, but maybe you can tweak it a little bit so that it does catch up during the night. Well, yeah, maybe we can, but what's the point of having master-slave if, when the master fails, you need to wait 3 hours for the slave to catch up before you can actually start using it as a master? So the big question here is, why is that master-slave lagging? So to understand that, we need to look at how master-slave works. So in the master, you have 16 cores. They're all executing queries. And as soon as one of them finishes executing a query, it will write the query to the binary log. It uses one CPU thread to do that. So it still has 15 to execute queries. Then the slave is going to copy that binary log file to its local file system using one CPU thread. And then it needs to execute everything that's in that binary log file, one query after the other, in the exact same order. So it can only use one CPU thread to do that. And that's where we have a problem, because we're executing 2,000 queries a second. The master can handle that with 16 CPU threads. The slave on one, that's not really going to work. So the master looks like this, and you see it goes up. The slave looked like that. It doesn't actually go up, the colors change, but it's already maxed out. So how do we fix it? What is our fix here? Any suggestions?
Use a where
Use?
Use a where update. Or different table for showing these data.
Using a different, yeah, yeah.
IDs and all the jobs shown, and then you want to insert all the IDs.
Yes. So you group basically your ideas of all the stuff that you want to insert into one table together. Basically what you create is what is called an extended insert. So you say, okay, I'm going to insert all these values, these 50 jobs that I looked up, into shown today, all of them at the same time. And then you can still do that on duplicate key. And that will work depending on whether that's already been inserted before or not. That will work just fine. So now we have, instead of 200 queries, we have 4 queries, which is very nice. And they wrote a piece of code. Took them 4 days to write this. I'm not kidding. And so basically this is very dirty code, but actually it works. So insert, and then they still do a for each, of course, but that doesn't take much time. And then they have to strip off the last comma from that, and then the unduplicate key is still there. And this works fine. However, we couldn't wait for 4 days because that slave was lagging, so we decided to do a quick fix. So we said, let's put db autocommit false at the top and db commit at the bottom. What it's doing now is basically saying, okay, we're still going to run 200 queries, but instead of writing them to disk after every single query and updating the indexes after every single query, we're going to run all these 200 queries, then we're going to write all these 200 queries to disk and update the index at the same time. And that takes a lot less time. So, we know that for loops are bad, we know that for a long time. Add a master slave, it gets worse. So if you have a for loop in there right now, and your DBA might at some point say, I need a slave because I want more redundancy, then it might screw up the whole thing. Using transactions in most cases will help you here. Be careful though, it might introduce some locking issues as well. In our case, the slave called up about 5 days later. We haven't had any issues since. Okay, so that's a lot about databases. I want to stop talking about databases now, and I'm going to talk about customer Y, because I want to talk about network for a second, because of course we use PHP, we communicate with the network the whole time. So customer Y had a big site, one of the top 10 sites in Belgium. They were growing exponentially, I would say. And the weird thing was, between 8 and 10 o'clock in the evening, they would have database connections drop, they would have weird results all of a sudden, and their site would behave very erratically. And they couldn't figure it out. We hadn't built any code on there, but basically they asked us, can you have a look? Because we don't know what's going on, and our developers can't figure it out. So we went in there and said, so okay, do you have any monitoring on your servers? And they said, well, we can see if they're online or not. It's not what I call monitoring, but so we installed a tool called IPTraf, and it tells you how much traffic goes across the network. And it basically told us that they were doing about 98 megabits per second. 98 is a bit too close to 100 for my liking. And it turns out they were doing 98 megabits per second from the database server to the web server, and doing that across a 100 megabit switch. So 98 plus a little bit overhead, yeah, equals 100. So we told them, look, this is your problem. You're just hitting the maximum capacity of your network. So they said, great, thank you. They swapped out the switch, put in a gigabit switch. Everything was running. Everything was perfect. They said, thank you. Send us the invoice. And we said, yeah, we will, but hang on. Your site is not that big. It should not be doing 98 megabits per second. So we started digging a little bit deeper, and it turns out they were transferring 700 gigs a day from the database server to the web server over that network. And then they were sending out 60 gigs a day to the internet. Now something doesn't add up here. I mean, what the heck is going on? Well, turns out they were using my favorite tool of all, called Drupal. And Drupal has a hook system. I don't know how it works in Drupal 8 now, but they were using Drupal 5 if I remember correctly. And so you can hook it into like a content block, and it will run all sorts of code if you don't write it properly. And then at the end it might decide, I don't need that code. I don't need the data I just retrieved. So that's basically what they were doing, initializing and running tons of queries and then saying, don't need it for this page. So the message here is only load the data you need, of course. If you don't know in advance which data you're going to need, well then use lazy loading. Load it the very second you need it. Then initialize it, not before. Now you might think, okay, that's okay, I'm using everything, I'm using a cache, I'm putting everything in Memcache or Redis or something, but you're still transferring the data across the network in that case. So, don't overload the network that way. However, there's more issues on the network that can happen. So, we had another customer, let's call him Zed. About 150,000 visits a day at the time, which was big for Belgium. And they had a news ticker on their website. Now that news ticker, that was actually loaded on every single page, actually on their homepage, and it loaded an XML feed from a site that they also owned. Now they didn't want to hit that other site every single time, so they cached it for 15 minutes. This is the actual code they were using. So we're going to check if a cache file has been created recently, like 15 minutes ago, and then if it's older than 15 minutes, we're going to delete it, we're going to do a file get contents of the feed, we're going to do a file put contents in our cache file, and then we're going to parse the feed. Can anyone tell me what's wrong with this code? Or what's not wrong with it? It's deleting before it's got the new one. We'll get back to that one. It's got a race condition, yeah, which is almost the same. Yeah, we'll get back to that one.
If it's a busy site, you might have 200 processes all refetching this at the same time. Yes,
if it's busy, you might get a lot of people going into that if. All these things are true. It's not what happened, though, sadly. So we had our web server, and then we had the feed source, and they were located on different servers, obviously, and they were located in different data centers, and that data center lost power. Now what happens if you do a file get contents after 15 minutes, the cache expired, you do a file get contents on something that's unavailable? It depends on the timeout. You get a timeout. So what's the default timeout in PHP? 60 seconds. So now you've got everybody on that site hitting the homepage, waiting for 60 seconds. Really? They're going to wait for 60 seconds? Nah, refresh, open a new tab. My Firefox is hanging, let me open Chrome. So you got more load, more load, more load, and they were using Apache, and at some point they just hit the maximum connections, and the entire site was now down. And we went in there and we're looking at it and like, there's zero load on the server, because every process is just sitting there waiting. But we got 400 Apache processes. That's kind of odd. Let's restart Apache. And like a minute later, exactly the same thing happens. So it took us a little while to figure it out, but in the end we did find out why it was happening. And so we had this piece of code, and then we told the developer who wrote the original piece of code, fix it. And this is the fix he came up with. It's not what I would call a fix, but so basically he's now applying a 5-second timeout. Yeah, they'll fix it, sort of. At least the site was live, but yeah. So there was a lot of stuff, other stuff that was wrong with this. So first of all, that unlink there, that shouldn't be there. We're not going to delete the cache file and then fetch the cache and put it there again. We just don't need that unlink. We can just push the new file to the cache. That works much better. Then another thing is, if we get a timeout, what is the output of file get contents going to be? False. So we're going to put false in our cache file. That's not going to parse very efficiently. So let's not do that. Let's check if the output of file get contents equals to false. Another thing we're doing here, it's kind of odd. We're doing parse XML feed every single time. Why? We could just do that once when we actually write the cache file. So let's put that in there. And then there's another thing that hasn't been mentioned here. File get contents and file put contents are actually not atomic operations. What that means is, if you have someone doing file get contents and you have another person doing file put contents simultaneously, you might actually be reading a file that's not completed yet. Or if you have two people going into that if structure, both doing file put contents, you might actually get a corrupted file. So you cannot actually rely on this entire mechanism anymore. So the only way to fix this is to say, okay, I'm not going to rely on the user here, because if I cannot know how many users are going to hit this piece of code. The only way to fix this is put this in a cron job, run it every 15 minutes. So the lesson learned from that is use timeouts for everything. And because a default timeout of 60 seconds is way too long, you need to set up a timeout for fopen, curl, soap, rest, whatever you're using basically. And if your data source is trusted like it was in this case, they were hitting a site that they also owned, then set it up as a web service so that the news gets pushed to you. You don't need to worry about a cache anymore. You always get the latest news. Of course, if you add logging, then you will know about it much sooner. Speaking about logging good. Logging using fopen, not good. You might run into all sorts of locking issues and stuff like that, so try to avoid that. But however, there is a good library and a set of libraries actually, but the one I like a lot is Monolog, because it allows you to log to all these and 50 others. And you can easily switch from logging to file, for example, to logging all of a sudden to HipChat, or, well, I wouldn't do that, but logging to other logging systems. And you don't have to rewrite your code to do that. Anyone using Firebug in Firefox? Anyone using PHP in Firebug? Not so many people. So PHP is very nice. It's an add-on for Firebug, which is an add-on for Firefox. And it allows you to write debug output directly onto your Firefox without it actually showing up in the page. And it will show up just in Firebug as an additional item there, an additional item in your console. It's very useful, and I would not use it to do debugging on production, but it's better than doing var dump on production or something like that. Now, it's important to watch our logs, because we all do that, right? Every day we go into our logs to see if we get any warnings or notices, right? Well, what's equally important is to watch our logging process, because if you log on slow disks, that might cause a serious I/O bottleneck. A lot of DBAs have a tendency to say, oh, our database should be on fast SSD drives, but our logs, yeah, slow old-fashioned disks are good. But if they can't keep up with them anymore, then your site is going down. So how do you detect that? Well, first of all, we need to know, of course, what causes it, which is excessive writing or excessive reading, obviously. Detecting it on Linux is kind of easy. You just type top, and then you get like all your processes, but at the top of top, it will say, okay, your system is spending this much time on user processes, this much time on system processes, and it will also say this many percent WA, which basically refers to I/O weight. In this case, our system is waiting 35.5% waiting on the disk to write or to read. That's not a good idea. Then you can type IO stat, and it will give you even more stuff. It will tell you exactly which device it's reading or writing from. In this case, it's 50%, 53%, so our system's spending half the time waiting for disk. That's not a good idea. If you see I/O weight higher than 10% non-stop, stop worrying about fixing anything in your code, fix the I/O problem first, because that's going to be your major issue. So we talked about a lot of stuff here. We talked about databases, how we should know what queries are running there and what kind of indexes we've been using. We talked about external locations and timeouts and stuff like that, how our code should really handle that. We're transferring data across the network. We have to know what we send across that network. Are we sending too much? What happens if we get a timeout? Is our code handling it? And so on. Web server stuff, well, that's of course PHP. I'm not going to talk about the PHP part of it right now. And there's the part that goes to the user. I didn't talk about that, but we could be caching stuff on the user side as well. So my message for today is basically, don't just look at the elephant. Look at how the elephant interacts with all these different pieces. Because we might all be very good coders, we can produce very good PHP, but if we look like that and only look at the PHP code, then we're not going to get anywhere. And it's not going to work in production, or at least it's not going to work in production tomorrow, even though it works on your laptop today. So look at the penguin and the dolphin and all the others, and then you can go from being just a coder to an actual PHP engineer full-fledged. Any questions? No questions at all. Yeah, go ahead.
I'm curious, with analyzing these problems with the shift to platforms as a service, are these things trickier to analyze in that environment? I'm assuming another customer on the same host is causing I/O problems. You're not going to see that in your I/O stat.
Yeah, that's a very good question. So the question is with the shift towards platform as a service and having multiple customers on a single machine, how do you analyze this kind of stuff? It is trickier, of course, because one customer might introduce an I/O problem because he's writing all sorts of data, making constant backups and stuff on his own system, and that can cause serious issues for other customers. It becomes a lot trickier. I didn't actually talk about it from that perspective. All these problems are basically from customers that were on their own dedicated hardware, but yeah, it becomes a lot harder then.
It depends on the platform as a service. So like it depends on who's running it. It's like with OpenShift, we can put sequence up against file I/O and limit each user to a certain guaranteed this much, but if you try to go above it, we can slam it. We do the same thing with CPU. We can do the same thing with network if we want to.
Yeah.
So if you're installing it yourself, there's all sorts of things. If you can't do real multi-tenancy, you're not real happy.
Yeah, there's a big difference, of course, between having like a virtual platform or just doing the old-fashioned virtual hosting, where you have one Apache running 50 customers on there. Yeah, that becomes very hard. You could split those up over different disks and so on, but I wouldn't recommend that. On most virtual platforms and cloud platforms, there are better ways of restricting access to disk and access to CPU and so on.
But it's still trickier unless you're the developer. There's no way they would be able
Yeah.
to see it. You'd have to get the admin to come in and say, look at your tools and see what's happening in this container or this container. Find the hot containers.
Yeah, it's always difficult to debug. Dedicated servers are always easier, of course. I think I have to clear the stage for the next person. I'll put the slides on SlideShare if you're interested in having a look at them. Thank you.